So lesson 17.1 was solving systems of equations by graphing. Well, lesson 17.2 is using the substitution method. So the learning targets are to solve a system of linear equations using the substitution method, and then interpret the solution of a system of linear equations. And I'm going to walk you through a note sheet on how to do this, just because the book doesn't do a great job of teaching it and it's kind of confusing. So we're going to do substitution notes on this note sheet. Okay, so bear with me. This is going to take a little bit of time to work through. You're going to see this again in Algebra 2, and this is important for the PSAT and the SAT. Okay? So, this is the first step. When one equation is set equal to a variable, or one equation is already solved for. So if I'm looking, notice how y is already alone here. So step 1 says to substitute the expression into the other equation. So what that means is I'm going to take this x plus 9 right here, and this is what y is equal to. So I'm going to plug this x plus 9 into my second equation where I see the y. Okay, and when I do that, the resulting equation should have only one variable. Not both x and y, only one variable. So, let me write it out. Start with this 3x plus 8, but I'm not having y anymore. Y comes out and sits on the bench, and I'm substituting in what y is equal to. So it's the x plus 9, and then I have my equal sign and a negative 5. So notice that this equation just has x's, because I know how to solve when I have the same type of variable. I do not know how to solve if I have both x and y. Okay? So step 2 over here, we're going to solve for the variable. So in this equation right here, the variable, the letter that we have, is x. Well, from first trimester, hopefully you learned how to solve equations. So solve for x. Now, this is a complicated equation, so it has parentheses, which means I need to distribute. So I'm going to multiply and multiply. So leave your 3x alone out in front, plus 8 times x, 8 times 9 equals negative 5. Now I have like terms here. So I'm going to combine like terms, CLT. 3x plus 8x gives me 11x. So 11x plus 72 equals negative 5. I want this 11x to be alone. I want my numbers or my constants together on the other side. So I'm going to subtract 72 from both sides. So 11x equals what? Negative 77. Perfect. Divide both sides by 11. X equals negative 7. Now, when we were graphing, we needed an ordered pair, x comma y. I'm not done yet because I only have my x. I don't have my y yet. Okay, so step 3, we need to substitute, hence the name substitution, your answer into any equation, whatever equation that you prefer, in order to find the other variable. In this case, my other variable here is the y value, right? I'm trying to find what that y is. And then when I substitute that in, I need to solve for that other unknown variable. I need to solve for the y in this case. So what that means is I'm going to take this x equals negative 7, and I'm going to substitute it right back in here for x into this first original given equation. I could plug it into the second equation if I wanted to, but that would be a little bit more complicated and more time consuming. So I'm going to work smarter, not harder. And the smarter or the easier equation is the top one. So y equals x, but I know that x is negative 7, and then I'm going to add the 9 to it. Okay, so I'm taking my answer of negative 7 and I'm substituting that in for x. What is, combine these like terms, they're both numbers, so negative 7 plus 9. So y equals 2. Okay, so step 5, we need to write our solution as an ordered pair, x, y. So that would be negative 7 to x always comes first, then the y, just like they're listed in the alphabet. X is first, then the y. So negative 7, 2. And I'm done. That's my answer. Okay, let's walk through another example. The more we practice these, the more we do math, the better you're going to get at them. Okay? Every example, every question is going to be different. But the process is going to be the same. Okay? So let's take a look at this one. So because x is solved for, because x is isolated, it's by itself, I'm going to take this expression 4y plus 7, and I'm going to substitute that into my second equation where I see the x. Okay, so this right here is going to get plugged in for the x in the second equation. So this is 2 times x. When they're smushed together, it means they're being multiplied. So it's 2 times, so put parentheses, 4y plus 7, end your parenthesis. Then I have negative 6y equals 12. And remember, when we write this out, this equation should only have one type of variable, y and y. So I know that I'm going to solve this equation for that variable, for that y. If I had an x and a y, I would need to go back and redo this and check my work and fix my mistake. Okay? . So when we see a number in front of parentheses, that means we need to distribute. So multiply, multiply. 2 times 4 is 8, and then put the y, plus 2 times 7 is 14, minus 6y equals 12. Now I can see I have like terms here. I have an 8y and a negative 6y, and they're on the same side of the equal sign. So I'm going to combine like terms. 8 minus 6 is 2y, plus 14 equals 12. We're trying to solve for this y, so I want this 2y to be alone. So we're going to subtract 14 from both sides. These cancel. 2y equals negative 2. Divide by 2. Y equals negative 1. So I know what my y is, but I am not done with this problem yet because I still have an unknown variable. I still do not know what my x is. So I'm going to substitute this into either equation. It doesn't matter. You could choose this first equation or you could choose this second equation. I'm going to choose the first because this looks simpler and easier. And I want to find x, and x is already by itself. So substitute into the first equation to find x. So that means I'm going to take this negative 1 and I'm going to put this negative 1 right here. Okay, right there next to 4. So let's write it out. X equals 4 times, instead of a y, I know that y is negative 1. So put in this negative 1 and then plus 7. So what is 4 times negative 1 plus 7? Negative 4 plus 7, we get x equals 3. So if I was to write this out as an ordered pair, because that's what the last step is, x comes first. So if you were to graph these two in slope-intercept form, like your intersection point would be 3 comma negative 1. So like my answer is 3, negative 1. Okay? All right, let's walk through the last question on this sheet. So y is solved for, or y is isolated. So we're going to take this and we're going to plug it in right here in the second equation. Okay, so this expression, 2x plus 4, goes right here. Now, I do not have a coefficient, a number in front of y that y is being multiplied by, so I don't need parentheses here. So I'm just going to write the 3x. This isn't working anymore. 3x plus 2x plus 4 equals 9. Step 2 says to solve for the variable. What variable do I have here? I have the x's. Now remember, if I made a mistake and I had an x and a y, I can't solve it, so I need to go back and fix it and check my work and start over. Okay? So I have like terms here. Let's combine them. They're on the same side, so keep the signs and just add 3 plus 2. We get 5. All right, I want you to keep going. Solve for x. You can do it. X equals 1. So step 3, I want to substitute this answer into any equation. So I could plug it in here for x in order to find my unknown, my y. Or I could plug it in here for x to find my y. It doesn't matter. But I'm going to work smarter, not harder, and I'm going to pick this first equation because this looks simpler or easier, less work for me. So I'm going to substitute this into my first equation to find out what y is. Okay, so this 1 is going to go right here for x. So this x is going to come out and sit on the bench. This 1 is its sub or its replacement. So y equals 2 times x, which is 1, plus 4. Two times 1 is 2 plus 4. So y equals 6. So then if we were to write this as an ordered pair, x comes first, comma, y. So our answer here is 1, 6. Okay, what I really want you to do is I want you to flip this over and go ahead and try question 1 on the back. So you want to take this, whatever x equals, and you want to plug it in for x in your second equation. Now you're going to get whole numbers for these questions. Okay, you're going to get integers, no decimals, no fractions. You can do it.